Hey, this is Jared with Uncontained Curiosity, and I recently had this cello museum website and organization reach out. They cover a lot of things that are cello related in the USA and UK, and they seem to be interested in my steel cello. So I have a few questions here I'm going to answer and talk a bit about the history of this, some of the things that I do, and hopefully you can see this end up in their online exhibition. You know, with all this going on, they're going to be doing a virtual exhibition of cellos, and yeah, so hopefully I can make my way in there and that there's more interest in this. I'll be sure to have a follow-up and post where that may end up, and kind of have a shout out there for the Cello Museum. So here's a few questions. Also, don't mind my cats; they're having the zoomies. So we'll try to get through this. So the first question is, what inspired you to make a cello? Well, if you can see behind me, I definitely love different stringed instruments. I also play the piano. I haven't really posted that a lot on this particular channel, but I'm a mechanical engineer by trade, and I do a whole bunch of other stuff. I'm always making something, 3D printing, and actually over here on the end is my first project I made, which was an electric cello. And the history on why it's not really complete right now is I had it playing at one point, but then I wasn't too happy with the setup, and the electronics got lost, and this was back in high school, and it just I didn't have like my 3D printer. That wasn't something that was even thought of at the time, or something that was at the consumer level. So there were some drawbacks in my ability. It was my first woodworking project, but at the moment it's in its last and final stages to becoming a completed electric cello. So I guess my inspiration for making this one was I previously worked for a company that involved a lot of steel and enclosures and industrial systems, so to work with sheet metal was a pretty regular thing for us. And I've seen a lot of projects for metal instruments, but they're typically aluminum, and they also were typically of the standard Stradivarius design. So I kind of had this concept of how the body needed to be that wasn't Stradivarius long before I thought of making it out of steel or even any other material, because the way that I've conceptualized the way that a cello should be built attacks many of the things that I ran into as a player and also as an engineer. So understanding a lot of material science and implications of damping and other situations that happen when you have different structural design, something that inspired me to finally make something that was both playable and kind of pushing the envelope of what you can do with the cello. So then the second question is the cello in the videos the only cello you've made, or have you made others? If so, how many? So I talked about the electric one that I made, and for my other cello that I grew up with, it's actually a pretty basic cello. It's like a Frederick Strobel from Music and Arts, and nothing too special about it. It's like a student level instrument, and but the thing is I remember when I was little and not really aware of all the intricacies of setup, the cello setup. I remember I broke my bridge and I took it to a luthier, and the luthier ended up just kind of lazily putting it on. It was the first time I was ripped off by something like that. It was unfortunate because I didn't know for actually a couple years after that, until I got to high school, and I had played with an instrument that had about like a 12 millimeter action from the fingerboard, and you're probably hearing that number, and thinking that's absurd, but like nobody ever looked, and so I pretty much practiced with like really high action, like from the fingerboard, uh, way out in space. So that wasn't fun. And I then myself, around the same time that this was now when I was in high school or kind of middle school, I took it upon myself to, well, the first time around, my teacher in high school, or yeah, early high school, actually showed me the process of filing and doing my own bridge. And then that one worked for a bit, but we pushed the limits of the bridge itself. Like there wasn't enough material to go where it should be. So finally, I did a little bit more work myself on one, and then finally I 3D printed a bridge for it. I do have a video on my channel that talks about 3D printing your own bridge, and the one that's on the Steel Cello and the one that's on my current cello are both 3D printed, and I have refined the design through many iterations. And actually the one in the video talking about 3D printing was an early design, so maybe don't reference that one if you're going to make one yourself. But it's definitely a really good solution to trying to get one made custom or having a luthier set it up. You're talking about $3 to $4 worth of material and a few hours of engineering work and design, and you can do many things that are the internal structure of the bridge, and just, you know, a lot of flexibility in the way that it's designed that won't give it that plasticky sound. You can make this isn't solid. It has an internal volume and everything. Number 3, how long did it take you to make your cello, and when did you make it? I think I heard you say in one of your videos that it took a week. Is that correct? Yeah, I took off work for an entire week, and like I said, I had the design in my head, and I had just gotten my first welder. I got a Hobart Handler 190, and I was using flux core, and I got the sheet metal from our local supplier that I had already worked with before. So I was familiar with them, and they also work with individuals as opposed to companies. So I just went over there, got 2 sheets of, one sheet of 18 gauge, and then I guess it was 836, and another sheet of 20 gauge. So the 20 gauge is like all the body, so it's not like really heavy, and then also the top of the fingerboard. And then for the structural parts, there's a rib going through this, the neck, and all of this that is holding tension. That's all the 18 gauge. And overall, if you're wondering about the weight, this weighs about, I think, what was it, 16 pounds? And then like my normal cello, it's like twice the weight of a normal wood cello. My other one's 8 pounds. This is like 2 of them in one. So yeah, I took that week off. I have the video on like basically explaining it, but I beat out the front and the back with a hammer. My neighbors probably hated me for those first couple days. Then I made the sides, welded it all down, made the body first. Then the neck is really what took most of the time, because I had to make all these bends without like a professional bender or like a English wheel. So all this was like hammered out. So I beat on all this stuff and like hand bent it, and then there's like 2 pieces like right down the edge, and then I mated them together, welded the front on, and that's when I got the experience myself of how much the metal moves when you weld. So a lot of adjustment over time of hammering out the low and high spots, and then finally I got these all, like the whole neck assembly and the body welded together. And then by the end of the week, I was designing the bridge and following the video on how to make a 3D printed bridge. From a material point of view, I think the total thing cost me like $160. I have like a more exact number in my how I made it video, but it was less than $200, and it's all basic stuff. I think I have like a inch and a quarter pipe for the end pen holder. I have the sheet metal, and then tuners and strings. So yeah, the strings probably the strings are on top of that, so add another like I think the set I got is like 120, probably less now. I think it's 90 now. Okay, so yep, 1 week. Started that Saturday, ended the next Sunday. I would wake up, sun would come up, sun would go down, and I would finish. So well over, I think 70 hours in total I put into it. What's the biggest challenge you faced making the cello, and how did you overcome it? Definitely that movement that happens when welding, because there's a lot of hand bends, so I couldn't like, the metal wasn't conditioned, and you had a lot of inconsistencies in the deformation that I had done. So then when you weld that, the heating and cooling of the metal makes it move around. It'll like potato chip or do a lot of stuff while you're trying to weld it together. So even though I would have had the body shape like already laid out where I wanted it, and I was like trying to make it perfect, then I would weld it and it would be totally different. You can actually see the biggest problem maybe here where it really dipped in, and I just never fixed that, and that's just honestly from it being my first project, and hey, it is what it is. Yeah, and how I overcame it is just doing it. There's lots of, it's not pretty, like if you really get up to the weld, they're not professional, but they work. You can actually see by the end here, when I did these last, I have some pretty fancy welds going on there that I'm kind of proud of, and then I just say don't look at anything else because it's not that good. Number 5. Is there anything else about your cello that should be included? Yeah. So, like I was saying about the design, there's lots of, like what I was saying, where every other instrument I've seen was either made by someone that was like not a player, like a fabricator, and they would make the instrument to copy that Stradivarius design. And in doing so, you had a lot of situations where the instrument didn't really sound that good, because it was made in context of something that should be made of wood. So understanding the implications of what metal will do and material thickness, things like Young's modulus and other material science things, damping ratio, things that are usually a structural problem, but also translate towards tone. With my knowledge of that and my engineering, I made a lot of changes to the design. So one of the main things is the rib down the middle. There's not like a bass bar because you really don't need it. You want to restrict as much structural supports, like because the metal's so strong, you don't need pieces to support it, but you also want the metal to freely move. You don't want something that's damping it, or like a part that is a supporting member that creates a joint that would restrict larger movements in the body, which would then translate towards more or less bass. So that's another thing, the size of the holes. They're really just kind of for looks. Nothing too special about their placement or size, but I knew if they were too big, you would lose a lot of your resonance. But I also understood the problem with, there's some structural things going on here where if there was too much material here, that would also restrict the sound. There was too much or too less, it might not support it right. So those are things I was mindful of, but it's just something I did. Like a lot of it was experimental, but there's like some intuition there, of course. Do you sell your cellos? If so, how can our readers place an order with you? So I thought about making my own, and as an engineer and project engineer by trade, it's definitely something I've explored the option of. Because there's so many hand fabric custom work, it's kind of like if you're into cars or motorcycles, like imagine going to like a custom motorcycle shop and having someone do English wheel work and custom fabricating a bike. It's really like that, but for cello, where if it was me doing it, which would be nice, I'm not at the skill level where I feel like I can sell them, or I can sell them with like a professionality to it, because it's like handmade. If people are interested in the handmade aspect, then yeah, I'll totally make them. And yeah, if they're into that, then if they want to play this one, it's the playability is there because I've been a cellist for over 15 years, so obviously I know how to make it feel, but it is different than a wood cello, and it definitely will have a consistent feel and playability. Let's see, in addition, we've got some photos, do some of that kind of stuff, and yeah, this is just the email that I got from one of the individuals there, and I hope this video will help. You can see the preamp on here. That's because I would perform kind of with this, and there was actually instances where I didn't even need to use this, like the battery would die, or I didn't have another hookup, and this is substantially louder than a wood cello. It's more efficient, and yeah, I'll play a little bit now, do a little bit of original stuff, and so you can get an idea what's going on here. Alright, so I'll kind of give you a tour of the instrument. I'll probably link this in the beginning of the video. Let's go through this. So first thing is the end pin. This is just a piece of 12mm rod. You get this at like McMaster-Carr. Just a whole bunch of material on there, really easy to get. I think it was like $5 or something. Welded that on there so that it wouldn't go through, and 3D printed this part. It's held up for now. I think it's been over 1.5 years. If you're ever concerned about the strength of the material, there's a piece of stainless steel 1/4-20 hex screw, and then I 3D printed with a pen, made the part on there. Next thing up here is again a piece of 18 gauge. This all used to look like this, but I didn't finish it, or I didn't like coat it, or I wanted to do some bluing, but at the time I didn't have the means to do it for this big of an instrument. So anyway, the whole instrument used to look like that. I wanted to go for like a patina, ended up not liking it, and I got it all back and then painted it with a protective matte finish. So the black is there, just kind of a stealth look, but more or less, maybe one day, or if I do another one, I want to do some bluing on the whole thing. And I've talked to some people that are skilled at that, and I think I have an idea on how to do it. So then this part's more reflective of kind of like a contrast in the rest of it, and then I clear coated it so it wouldn't rust. Same here, that's like a welded bead, 3D printed. So you can see here it's got kind of some holes in it, and then I guess my logo. It's like something I designed. It's supposed to be like my last name. It starts with an H, so put that little H in there, and the holes are actually functional for the sound and to keep it from bowing, because this isn't solid. It's actually got like space inside. And when there's these little holes, they add a little thing of support here. They add extra internal walls. So that adds to the structural rigidity of the legs without compromising or damping the sound. And also potentially creating a too harsh of a tone, because when you have solid PLA like this, it's a very dense plastic, and therefore it transmits the higher frequencies more readily than the bass. So I've been through many iterations of these, and I really like the tone and the rigidity of this design, and it's held up for over 1 year now, and you can see perfectly straight for all I want. Next thing is the weird preamp setup. I already talked about that. So just imagine that's not there. This is hollow. Actually, the whole thing doesn't have like, it's not like a piece of tube or anything that I cut out. There's like lots of open and internal volumes. So this is a sheet, and then under here's a supporting sheet. So then that's a volume all through there, kind of adds some resonance. The rib goes all the way from here to here, and it's shaped a certain size and in a certain kind of shape there to act like as a bridge for the face, but also to allow some resonance. When it comes to the back, and actually there's no there's no sound post, and I did that because the sound post will do two things. It will tighten up the sound, and sometimes it restricts the tone. I know it's supposed to transmit the sound from the front to the back, but it also focuses the sound. If you already heard, this kind of has its like own, like it just rings. It rings for days, and I didn't want to lose that kind of tonality to it, and I liked keeping my other cello to fill that gap in tonality. Next thing here, the whole instrument's 6% bigger than a normal cello, but because of the way that your first finger, fourth position interacts with the next string there, your fifth, I needed to make sure this curve was in the right place and that the scale length was correct. So I tried to model this as closely to my normal cello, but there is some slight changes because of the scale length, and from my point of view, it actually plays really well, and that little nook right there seems to be right in the right place, and then also here added a little fanciness. If we go in here, we have these precision bass tuners. When I do this again, I'm probably gonna get a higher quality set, and then also I think I'm gonna do some like something with a pipe here that supports the tuner from the other side, so that it's channeled in. Because at the moment you can see on some of these, like the lower strings in particular, or yeah, the G and the C kind of have that effect, a little bit of the D, but if you were to look at it from this point of view, they are pulling on the tuner and they add a lot of bending stress to the tuner, and the tuners work, but it's not necessarily a good solution to that problem, and it's not going to be good for the tuners over time. Finally, this design here, just something I had in my head, like a hook. I didn't really want to do a scroll, nor would I probably have had the ability to make it look good. But I like the hook because you can hang it from stuff, you can hang things from it, and yeah, I think it's a nice look for it. If you go to the back here, you can see that's also hollow, so you can stick your finger in there, but there's the face here and then that part. And yeah, it's pretty much a tour of the whole instrument, and I think the last thing I left out is that's also 3D printed. So everything here I can just, the steel is going to last forever basically if I don't let it rust away. And if I need to create another nut or bridge, I can just 3D print it and slap it on there, call it a day. So yeah, kind of implementing new and old-fashioned fabrication and new technology, and I hope you like the instrument, and maybe if someone wants to buy it, well, not this one. I've reached out to the piano guys, and they're like, yeah, we're interested, but you'd have to give it to us, and I can't give this up. So it's too cool, and if I have some other opportunity, then that'd be really nice. Have a good one. This has been Uncontained Curiosity for the Cello Museum, and have a good one.